So we begin with our fourth and final class of relation and function. I wanted to do 5 classes, but checking the reduced syllabus, I found that the fifth class is not required anymore. So I really don't want to waste too much time on a single chapter. So I will be concluding this chapter with this class. And this class is going to be a little bit theoretical and requires a bit understanding, for the matter of fact, because we are going to deal with some particular point which most of the time or years after years I have seen that students face difficulty understanding. So we are going to talk about real valued function. Now no more it is 1, it is just real valued function. Now we already discussed a little bit of it in the last class. We just talked about the several different kinds of real valued function we have. Now we will be going through some of them which we require in this class. So the first one which we are going to come across is the piecewise function. Now the piecewise function is basically a very important class of function which we will be requiring. Now how does it work? Let us see. So let us take the first one, that is fx equals to x minus 1, x is less than 2, and 2x plus 3x is greater or equals to 2. Now can we consider this as a piecewise function? That is the first idea. But before we can consider this as a piecewise function, let me just give you an idea how it works. So it is basically a function. So if this is our coordinate axis, this is my y-axis, this is my x-axis. If I go on plotting the function, so this is 0, here it is 1, here it is 2, here it is 3, and so on, and this side it is minus 1, minus 2, and so on. So this is how the function looks like. Now this is what the idea is. Now the function will follow a particular branch when x is less than 2. So it will follow a branch when x is less than 2, that is the function will come something like this. It will come it will come something like this. This is the first graph, that is when this is the graph of y is equals to x minus 1 till x is 2. Then as x becomes greater or equals to 2, it will follow another graph, so something like this. So now see what is the difference. If I am following this graph, the function is something like this, that is this one, and in the next one the function is something like this, right? So it means what? The function, there are two different functions clubbed together in one, that is to a certain point. For in this case it is 2, the function is following one graph, this one, and not exactly up to 2, less than 2. From 2 and onwards the function is following another graph. So this is the idea of piecewise function. Next, let us take another example. So say this is the example, that this is from 0 to 4, the function is 0 less than 4, the function is following this graph, that is x square minus 4, and it is following the graph 3x when x is greater or equals to 4. So now if I am drawing this graph, how does it look? Now x square minus 4, we need to understand what does it represent. So always remember, any quadratic expression represents a parabola, which we will be dealing with later. So starting from 0 to 4, so from 0 to 4 it will be a graph like this. So here it is 4, say this value is 4, and starting from 4 it will follow the graph 3x, so something like this, a straight line. So if you just draw it, plot it, you will be seeing I am giving you a rough idea. So what was the difference between the first one and the second one is, in the first one there was a gap. Why? Because if you see, if I follow the left hand curve, 2 minus 1, the value is 1. If I am following the right hand curve, 2 into 2 is 4, 4 plus 3 is 7. So therefore at x equals to 2, I am getting two different values. Or just before x equals to 2, I am getting a different value, and at x equals to 2 and afterwards I am getting a different value. So the function had a gap in between. But in this case, if you see, if I put 4 here, x square is 16, 16 minus 4 is 12, and if I put 4 here, 3 into 4 is 12. So therefore, what is the difference between the first one and the second one is that both are piecewise function, absolutely right, but in the first case there is a gap, there is a discontinuous gap, and in the second case there is no gap but the function is continuous, right? So this is the difference how piecewise function work. We will be requiring it in our future chapters, so that is why I am just making you understand how it works. Next, let me take another example. Fx equals to x square when 0 less equals to x less equals to 3, and 2x when 3 less equals to x less equals to 5. Now, is this a piecewise function? Is this a valid function? That is first we need to address. See here, x is taking the value 3 in this branch also, x is taking the value 3 in this branch also. Now in this case, the value of fx when I am putting x equals to 3, when I am putting x equals to 3 is actually 9. And again in the second branch, the value of f when I am putting x equals to 3 is 6. So these two values do not match. Now if they do not match, I can't call this to be a function at all. Why? Because the idea of function is that for any particular value of x, it must have only one unique value. If I am getting two different values, that means what? It doesn't remain a function. So therefore, this one may look like that it is a piecewise function, but it is actually not. So this is definitely not an example of a piecewise function. For the matter of fact, it is definitely not an example of function. But in the other two cases, these two are definitely functions. Now you may ask the question that here also I am getting a different value, here also I am getting a different value. Yes, I am getting a different value which is less than 2. So when x is equal to 2, I am always following this one, not this one. But the graph of the function will have a gap. Why? Because there is quite a large difference in the values. So therefore, for no value of x, I am getting repeated values. So therefore, these two are valid functions. But in this case, I am getting a repeated value at x equals to 3. And therefore, this can't be considered as a function. Okay. Now, let us move to the next one, the next very important function which we require, that is the modulus function. Now modulus function, it looks very humble like this, fx equals to mod x. Now this function basically represents two different functions which we need to understand. So let me take one example and make you understand. When I am writing modulus of 5, it is giving me 5 exactly. It is returning me the same value. But when I am writing minus 5, it is giving me 5. So that means what? The modulus function gives me a negative of the number when it is a negative number inside. That means how am I getting this 5? I can write this 5 as Mod of minus 5, I can write this as minus of minus 5. See, if I am putting a negative sign outside, this is actually giving me 5. So when x is negative, it is giving me the negative of that number, and if x is positive, it is returning me the same number. So therefore, I can write mod x as something like this. See, just understand the idea. It is returning the negative of the number if x is negative itself, and it is returning the same value if x is positive. So therefore, modulus function is basically a piecewise function in disguise. So you can always convert a modulus function into piecewise function. Next, let us take another example. Say fx is equals to mod of x minus 2. Now how to understand that it is becoming this? That is something we need to discuss. Say if I put any value of x, say if I am putting the value of x as 1. If I am putting the value of x as 1, what is the inside number? Mod of 1 minus 2, that is becoming mod of minus 1. So mod of minus 1 is basically minus of minus 1, that is your 1. So I can see if I put any value of x which is less than or less than 2, it will always give me a negative value, and in turn it will be giving me the negative of the negative value outside the modulus. So therefore, till x is less than 2, I will be given the negative of the number. When x becomes greater than or equal to 2, it will give me the positive value. So randomly, if I am given any modulus, how to break it into piecewise function? So say for example, I am given x plus mod of x plus 1. How to break this into a piecewise function? First is find the value of x for which the function gives you a 0 value. So if I put x equals to minus 1, see minus 1 plus 1, it is giving me 0. So therefore, the branch will be on the point where x is the function is giving you 0 value. So x will be less than minus 1, that is one condition, and x greater than equals to minus 1, that is another condition. Now obviously greater than or equals to, you can write here less than equals to, and you can write here greater than, doesn't make any difference. Now when x is less than minus 1, it is going to give you the negative value, that is x plus minus of x plus 1. And if it is greater than equals to minus 1, it is going to give you the positive value x plus 1. Right? So this is how you break any modulus function into piecewise function, which is very important because we need to break the modulus functions into piecewise function for our future references. Now let me take another example and let me just clear this idea out. Let me put say I am trying to find out 2x plus 3, mod of 2x plus 3. I am trying to break this into piecewise function. So first let us find out which point gives me 0. So see, if I put x is equals to minus 3 by 2, it gives me 0. So therefore I will have a branch which will be x less than minus 3 by 2, and another branch when x greater than or equals to minus 3 by 2. So there will be these two branches, right? Then on the left hand side of this, I will get a negative value, so this will give me 2x minus of 2x plus 3, and on the right hand side I will get the positive value, that is plus of 2x plus 3. So therefore this is exactly how you break any modulus function, which we will require right after a few moments. So this is the idea of modulus function. Now before I go into example 1, let me just clear out another important thing. Here we will be talking about the idea of domain and range. So before we go on finding the domain and range of any function, let us understand how it works. Say for example, I have this box. This box is a machine and I am naming the machine as F. So this is my machine. This is a machine. Now I am putting something inside. So I am putting inside some x inside the machine, and the machine is doing what? Machine is working on this x, and it is giving me a value y, right, which we can also call as f of x. F of x means that x has been worked upon by the machine and it is giving me this value. So x is my input and this fx or y is my output, right? Now obviously for not all machine you can put anything inside. Obviously each and every machine has got its specification. You can put particular types of item inside that machine and the machine will give you out some particular types of product. It is not going to give you any product. You definitely can't expect that a soda factory, the machine will give you burgers. You can't, right? So therefore the idea is there are particular values of x which can go inside the machine and there are particular values of y which can come out of the machine. So therefore all those values of x which can go inside the machine, that constitutes the domain, and all those values of y which is coming out of the machine, that is constituting the range. Fine. So domain means it is all possible value of x that the function can take, and range means it is the all possible value which the function can give. So this idea is very important. Now also remember this, that not all values of x can fit inside a particular function, and also not all values of y can be an output of the function. So therefore all the next few questions as we are going to deal, we will try to understand and find out what are the possible values of x the function can take, which will be our domain, and what are the possible values the function can give as an output, which will be our range. Fine. So let us take the first example, simple one. So we were just warming up. So this is something which we have already done in our previous class. So you are given fx is equals to 2x square plus 1, and you are told that this is the domain of the function. You are given the limited values, that is -2, -1, 0, 1 and 3. Then first job is to find the range. Now again just follow the idea. What is the meaning of range? It is the values which the function is giving. So therefore how to find it? I will be putting all these values. I will be putting all these values inside the function and I will calculate. After calculation, whatever the values I get, that is my range. So put -2 in place of x, do the calculation, find out what you are getting. Put -1, find the value what you are getting, and so on. So therefore if I do our calculation, which I am leaving up to you, do it and you will get that the range of f is this 93139. I have made a mistake here. Please ensure I made a small mistake. That mistake is I wrote 3 more than once, which is not the correct thing. It should have been if I am writing in ascending order 1, 3, 9 and 19. That should have been the answer. I by mistake wrote this 3 once, so this is not correct. So my answer is this basically. Now from where am I getting all these values? Just take one value, put -2. So f of -2, so that is 2 into -2 whole square plus 1. So -2 square is 4, 4 into 2 is 8, 8 plus 1 is 9. So like this way, if you go on putting all the values, you will see that this is exactly what you get. So therefore this is my range. Clear? Next is easy. You have to find what is f of 3 into f of minus 2. You already know what the values are. Multiply and write what the value is. 9 into 19, that is 171. That's what it comes. Then next, what is the value of x if fx is 9? Now obviously I have found that for x equals to minus 2, fx is giving you 9. So therefore value of x is minus 2. Fine. Next. Question number 2. Similar question, just I am going through. Fx is given x squared plus 3. It is told that x is a natural number and x is less equals to 5. So therefore you are already told what is the domain. So what is the domain? Domain is your 1, 2, 3, 4, 5. This is already told that this is your domain. Now you have to find what is the range. So same thing, put the values and calculate. So if you put the values and calculate, your range comes exactly like this. Then the next is find f2 into f5. Those are routine work you can do. Then does f of minus 3 exist? Now obviously f of minus 3 does not exist. Why? You can see very clearly because you are given that x belongs to the set of natural numbers. X belongs to the set of natural numbers and x is less equals to 5. So domain values are 1, 2, 3, 4, 5. Minus 3 doesn't fall inside the domain. So therefore f of minus 3 does not exist. So you can just write it like this, that as minus 3 is not in the domain, so the value does not exist. Then the last one, the same similar problem. You have to find the value of x when fx is 7, and by calculation you can see that x is 2. Clear? Simple enough. Next one. From here we are going into some uncharted territories. So some little bit of difficulty there can arise. There will be arising in understanding. So let me go a little bit slow. You are told to find the domain of the following real function. Domain of the following real function means when I am told that it is real function, I know that x is taking all the values from the set of real number. But as I told you that fx is actually a machine. It can't take all the values of x. There will be some limited amount of values it can take. So I need to find out what are the values it can't take, and I will be just throwing it off from the whole set of real number. Right? So let us do one, then you will be understanding. So this is what it is given. Fx is equals to x squared minus 4 and x plus 2. Now you see this function has got a denominator part. This function has got a denominator part. Now for any value to exist, for anything to have a value, and if it has a denominator, I must ensure the denominator is non-zero. If denominator becomes 0, then something bad will happen. What bad will happen? That the value won't exist. We won't be getting any value because anything divided by 0 is undefined. We don't know what division by 0 actually is. So therefore, I can't let the denominator become 0. That is my first and foremost criteria. So leaving that, I don't see any other problem, right? So therefore, at the point where the denominator is 0, if I exclude that point, then for any other point or any other value of x, the function will give me a value, right? Means what I'm trying to say, the machine is not going to work when the denominator becomes 0. So if I try passing that value into that machine, the machine won't work. So I have to ensure I leave that value out, and leaving that value I put any other value inside. I will always get a product out. I will get any value out of it. So if I do some inspection, obviously this is exactly what I said. If I do some inspection, then I can see if I put minus 2, if I put x equals to minus 2, then the denominator is becoming 0. So therefore, if I leave that value out, if I leave that value of minus 2 out And if I put any other value I want, doesn't matter what, if I go on putting any other value I want, I'll definitely get some value of the function. You see why I can put x equals to minus 2. If I put x equals to minus 2, see what happens. There will be some blunder happening. So what happens if I put f equals minus 2? Minus 2 square is 4. 4 minus 4 divided by minus 2 plus 2. So this is giving me 0 divided by 0. So 0 divided by 0, that is no value at all. I don't know what value that is. So this is basically called an indeterminate value. Indeterminate value, or indeterminate form rather, which we will be discussing in class 12 in length and at length and breadth, which is a complete chapter itself. So therefore at minus 2 I can't put this value. I can't put the value. So leaving minus 2, I can put any value I want, and I'll see that I'll get some value or the other. So therefore this function can take all different values of x except minus 2. See, it can take any value other than minus 2. Clear? So therefore, what is the domain? Domain is the whole of real number minus this single point minus 2. So I can write the domain as something like this. That is the whole set of real number minus only the single number minus 2. Or if I want to write it in the form of intervals, this is how I write, in the form of intervals. Now, how to understand that this is exactly what is happening? Draw the number line. This side it is minus infinity, this side it is infinity, and I have this value minus 2 somewhere in between. So if I just leave this value out, minus 2, what am I left with? I am left with this whole number line from minus infinity just before up to minus 2, and on this side starting from minus 2 or just after minus 2 till infinity. So therefore this is exactly what it is in the denominator form. Now you need not draw the number line, you can just do it in rough and understand what the value is going to be. This is also a valid answer, this is also a valid answer in whichever form you want to write. Now writing in the interval form is more accepted. Why? Because we already have done linear inequality, so we already know how to write it, the interval notations. So I told you that we require the idea of linear inequality here. So this is exactly one of the reasons why we required it, to write the interval notations. Okay, clear? Let us take up another example. Now example number 4. We are trying to find domain of the following real function. We are just taking a different function. This is the function that we take. Fx is equals to x by x square plus 3x plus 2. So the same idea, the function will be giving me any value except all those points of x where the denominator is non-zero. So except where the denominator is 0. So let me try finding out which are the points where the denominator is giving me a value 0. So by putting denominator equals to 0, I will get a quadratic equation, and I think I need not tell you how to solve a quadratic equation. So do the middle term, solve it, and then I get the value of x as minus 1 and minus 2. So in the last problem I got one value, only one single value, but here I am seeing that I am getting two different values. So therefore the idea is all the same. The function can take any value other than these two values. If I pass these two values to the function, I'll see that I'm not going to get any value. So therefore the domain is going to be the whole set of real number except these two particular values. And again, if you are writing in the interval notation, this is what you get. How to understand? This is what I have got. Draw the number line. Here it is minus 2, here it is minus 1. So I will consider here it is minus infinity, here it is infinity. So I will leave these two values out and I will take all the other values. So therefore from minus infinity I will take up to 2, or just before up to 2, and then after minus 2, I will take all the value till before minus 1, and then again I will take from minus 1 to infinity. So I am getting these 3 different intervals. Fine. So just I have given you 2 different ways of writing the domain. Suit yourself whichever you find the best. Next, problem number 5. So here also I am trying to find out the domain and domain of the function. What is the function given? Fx equals to mod of x plus 2. So fx equals to mod of x plus 2. Now I already told you that we can always break a modulus function into piecewise function. Now, is there any hard and fast rule that I need to break it into piecewise function? The answer is obviously no. If you have understood how modulus function works, you can work with it directly. No need to break it into piecewise function. But if there is some lack of clarity, you haven't understood it, or you are not well accustomed with the modulus function or working with a modulus function directly, you can always break it into piecewise function. So I am breaking it into piecewise function for you. So this is exactly what it is. This is how the piecewise function work. Now I have to see if there is any value of x which I can't put in f, for which I am not getting a value. Now for a modulus function, remember this, whichever and whatever the modulus function be, the good thing is that this modulus function doesn't have any denominator, doesn't have any such criteria where I can't put any value of x. You see, if I put any value of x, it will definitely give me some answer for sure. Now this is by inspection. I can say directly that I can put any value of x, I can always find some answer. So therefore I can directly say that the function exists for all value of x, means there is no value of x for which the function is not going to give me a value. So therefore I can say that the domain is the whole of real number. Any real number I can put and I will always get some value. Fine. So and also if you are writing it in the interval form, I know real number means the from minus infinity till infinity. Clear? Now just for heads up, if you come across any modulus function, be sure to write domain as the set of real number always. Why? Because your modulus function can take any value. Now if you are asked to find what is the range, which is not part of the question obviously, but I am telling you. Now I know modulus of any number that can be either 0 or greater than 0. So therefore range will be always the positive real number, any positive real number or non-negative real number. So that is written in the form r plus 0. This is the notation which we write, r plus 0. R plus means positive real number, and putting the 0 in the suffix means 0 is also included. So all non-negative real numbers basically, right? Or if you want to write it in interval notation, it will be basically this, closed 0 to infinity. So it can give you the value 0 as well as any positive real number, no negative real number at all. Fine. So I have done it for you here. Range is from from 0 to infinity. Now this is true for any modulus function. So if I would have had mod of x plus 1, I would have had mod of 3x minus 2. If I would have had mod of x square plus 5x plus 6, doesn't matter what, I will always have this 2 correct. Always. Why? Because for modulus function, it always gives you these values. Means that it can take any value and it will give you any non-negative value. Then there is one catch. The one catch is, instead of having it in the numerator, if I would have had 1 by mod of x plus 2, how to deal with this? Now obviously again the idea is all the same. See, it is in the denominator, so now I will find that point where it is giving you the value 0. So I will exclude that point and I will take any other value. See, so it is giving you 0 at -2. So instead of this becoming your domain will become r minus -2. Clear? So always remember that. So this is not the property of the modulus function, but it is the property of the function being in the denominator. So always remember, whenever anything is there in the denominator, I will just cancel out those points where the value is becoming 0 in the denominator. Except that, I can take all the other values. Fine. Next, example number 6. Now there are 3 different examples. I will solve 2 and you can try solving another one. Now the question is, find the domain and range of the following functions. So this question will have both. You have to find both the domain as well as the range. Now before I go on solving the problem, let me tell you this, that finding domain is easier than finding range. In some cases finding range can be really difficult. So therefore we already have actually understood how to find the domain, that is finding all those possible values of x which it can take, but it is little bit difficult to understand what are the possible values the function can give, which is very important. So now let us take 2 examples. Let us understand how it works. So in the first case, this is what you are given, right? Now you will be tempted to do what? You will be tempted to write this exactly as equals to minus of x minus 4 by x minus 4, which gives you -1. So you will tell that, sir, it does not depend on x, so it can take any value it want. So I can put all values of x, but the answer is no, it can't. Why? Because you see, this manipulation is not allowed directly. Why? Not allowed directly, as here if I put the value x equals to 4, if I put x equals to 4, see what happens. If I put x equals to 4, f of 4 is actually going to become 0 by 0 once again. So 0 by 0 is not the desired result or desired value we want. 0 by 0 is no value at all. So therefore the idea is all the same. I can't take any value for which the denominator becomes 0. So therefore here, to keep the denominator non-zero, what I have to do? I can't take the value 4. Clear? If I take 4, then the denominator becomes 0, then the function is not going to give me any result. Now once I know that x is not 4, I mean I am not taking that value for which the denominator is becoming 0, then I can definitely write that this is my domain. I am taking any value of x other than the value 4. Fine. Now for the next part, that is to find the range. Now once I know x is not 4, now I can do what you were tempted to do. Exactly. Now I can directly do the cancellation. I can write it as minus of x minus 4 and then divided by x minus 4, and then I can write it as -1. So always remember that looking at the function directly, if you feel like cancelling the factors out, that is something which you are not allowed to do. Why? Until and unless you find out those points where the denominator is becoming 0. Because if I do not find the values where the denominator is becoming 0. What I am trying to do is that if I go on cancelling it out, I am actually cancelling out something like this. Minus 0 divided by 0. So 0 and 0 are same number. I am cancelling and I am writing it as minus 1. It becomes something like this. So which is definitely not correct. So therefore I have to have some non-zero value, then only I can write. So if I would have had minus 2 by 2, I can write it as minus 1. If I would have had minus 357 by 357, I can write it as minus 1. But definitely minus 0 by 0 can't be written as minus 1. So therefore, at the beginning I can't do the manipulation which I have done here. So first I need to take out that particular value of x which is giving me 0 in the denominator. After I have taken that value out, means I have defined what the domain is by leaving that value out. Now I can do the manipulation, which I am allowed to do. Now, once I have understood this, see what is happening. After I have done the manipulation, I am getting the value minus 1. Clear? Now, this value minus 1 doesn't depend on the value of x at all. So whatever x you put, doesn't matter what, it is going to always give me the value minus 1. So therefore, what is the range of the function? The range of the function is singleton minus 1. Singleton minus 1 means this function gives me only one value, and that is minus 1. Doesn't matter what. Except the point 4, of course. For all the other valid points which the function can take, it always gives me the value minus 1. Fine. So this is range. So now for this problem, finding range was easy, but for other problems it may not be. So let us take another example and see. Let us take the second one, that is x squared minus 9 by x minus 3. So again, x squared minus 9 by x minus 3, you may be tempted to factorize and cancel out the factor. Don't do that. I told you once again that until and unless you find out or leave those points out where the denominator is becoming 0, you can't do the cancellation. So let us find out what is the point where the denominator is 0, because I have to leave that point out for the domain. So I can see directly that x can't be 3. 3 is the value for which the denominator is becoming 0. So therefore, what is the domain? Domain is this. We have already understood the idea how to find the domain, so it is easy. Now once I have cancelled out the value for which the denominator is becoming 0, now I can do the manipulation which I am looking for. So I can factorize and I can cancel out. So I am getting x plus 3. So now you see, once I have got this, so this is basically giving me what? So fx is becoming x plus 3 for all possible values of x except the value 3. Isn't it? X square minus 9 by x minus 3 is basically this only, but only for all values of x other than 3. So therefore, what will be the range? Here you can see I can put any value of x except the value 3. So if I would have put the value 3, what value I would have got? I would have got the value 6. If I would have put x equals to 3, I would have got here 6. So as I can't put the value 3, this function is never going to give me the value 6. It will give me any other value but other than 6. It will give me all possible values there can be, but it will never give me the value 6. And therefore, the range will be any real number but not 6. This function can never give me the value 6. Clear? So that is how we find domain and range. It will take a little bit of time to understand. I am pretty sure it's a little bit confusing with all different logics that goes behind it, and obviously right coming from class 10 directly, you are given this and you can't do the factorization seems a little bit awkward, because all the time till now, whenever you would have got something like this, you would have just done the cancellation directly or blindly without knowing the things that goes behind. These are the certain things which that is very much important. If these things are not there, you can't do the cancellation as you want. So therefore, give yourself some time, understand this, and once you understand this, I'm pretty sure it will be easy for you to solve. I am leaving the third one out. Do it for yourself, you will understand. Okay, let us move to the next type of problem, and this is the last type, hopefully. Similar question, but here I have got some square roots. So once again, now here finding domain is going to be easy, but finding the range, we require to apply a new different kind of technique. So we will discuss that. Before we go on discussing that, let us take the first example and find the domain. Now see, whenever I have an under root quantity, whatever the quantity be, this quantity has to be positive, or better, it can be non-negative. If I shouldn't say positive, I should say it is non-negative. What is the difference between being positive and non-negative? Positive means I am considering only the positive values, but when I am saying non-negative, it means it can be 0 as well as positive. So therefore, under root quantity can never be negative. We already know that negative numbers does not have a square root. We already know that. At least till now we know that. We definitely will come across different part of mathematics where negative numbers can have a square root, but let us not deal with it. Why? Because we are working with a real valued function, so everything is real, and we know that no square of real number can be a negative number. So therefore, in that line we can also say that no negative number can have a square root. Forget it, no real square root. Okay, so therefore this function will give me any value, or this function will give me some product out of it only if this inside quantity remains positive. If it is not positive, say for example, if I put x is equals to, say for example, 6. Say for example, if I put x equals to 6, then it becomes root over of 16 minus 36, that is root over of minus 20. So this does not remain a real value, right? Because I know square root of negative number does not exist. So therefore, I have to find out all possible values of x where the inside quantity remains greater than 0, greater than equal to 0, of course. So therefore, let me solve this inequality, that is 16 minus x square greater or equal to 0. So now you understand where our inequality topic theories are coming into use. So this is exactly where it is coming into use. So 16 minus x square greater than 0, we already know how to solve quadratic inequalities, so just use it. So 16 minus x square, you can write it as 4 minus x, 4 plus x greater or equals to 0. Draw the number line, find those plus, minus, plus, whatever we know already we have done, so I am not discussing that part. So from there I can see that x belongs to minus 4 comma 4. If you draw the number line and check, you will see that x is belonging to minus 4 comma 4. So therefore this is exactly what my domain is. So the value of x has to remain between minus 4 and 4. Otherwise, if you take any other value outside this, then the function will not give me any value. Now comes the difficult part, finding the range. Now for the previous problems, as we saw that we can algebraically calculate and find what the range is, but for the square root functions it is a little bit difficult to find what the range will be by any calculation. So what we do instead a trial and error method. What is the trial and error method? We will be making a table of values. I will be taking some value of x and I will be finding out what is the value of fx. Now I know that x can take value from here, so I will try taking all those values. So take minus 4, then say minus 3, minus 2. I need not take all the values, mind you. I need not take all the values. Let me take 0, let me take say 1, let me take 3, let me take 4. So I will be trying all values and I will try find out what the value is. So if I put minus 4 here, I will get 0. If I put minus 3, that is 16 minus 9, that is root 7. If I put minus 2, that is 4. 16 minus 4, that is root 12. If I put 0, I will get 4. If I put 1, 16 minus 1, that is root 15. So and so on, I will get. Now, if you just see, the minimum value that I am getting is 0 and the maximum value that I am getting is 4. And I am getting all the values within 0 and 4, but definitely not less than 0, not possible also, and also not more than 4 as well. So therefore, my range is from 0 to 4. So that means this function can take values between minus 4 and 4, means all the values of x can be between minus 4 and 4, and this will give me all the values between 0 and 4. Clear? Idea is clear. So this is basically it. Now let me take another problem and solve, which will clear your idea out. So let me take the third one, that is 1 by root over of 4 minus x square. Now 1 by root over of 4 minus x square, this one, you see, as it is in the denominator, I will take all the values of x for which, so I have two criteria to tackle now. What are the two criteria? The first criteria is I have to ensure that under root quantity is positive. I mean non-negative rather than that. And also, as it is in the denominator, I have to ensure that it is positive but not 0 as well. The under root quantity cannot be equals to 0, because if it becomes equal to 0, then the function will not give me any value. So therefore, I have to ensure the under root quantity remains strictly positive, not even non-negative, but strictly positive. So therefore, what I have to do? I have to solve this 4 minus x square, but the last time we solved it as greater than equals to 0. This time we are going to solve it as only greater than 0. Now, after doing the calculation and doing all those things that we already know, I can see that x belongs to open interval minus 2 and 2. Obviously, if this would have been in the numerator, I would have taken closed interval, but it is not in the numerator, so I will be taking open interval. So therefore, this is, oh, come on, I did this mistake. This is not minus 4 and 4, this is minus 2 and 2. This is a typing mistake, so please excuse. That's a typo. Okay. Now, so minus 2 and 2 is my domain. Fine. Then I have to find what is the range. So for finding the range, I will do the same thing. The idea is all the same. I have to plot all the values by taking all different possible values that I can have. So let me take the let me draw it. So let me take the values of x, fx. Now what are the values I can have? Minus 2, let me take 0, let me take 2. Now obviously you will be asking this question, why are you taking minus 2? Now obviously, okay, let's not take minus 2, let's take something different. Now obviously if I put minus 1 here, I can see 4 minus 1 is 3, so that is 1 by root 3. And if I would have taken 0, it is giving me half, and if it is 1 by root 3. Now you see, if I take any value closer to minus 2, so let me take 1.5 or so, and if I go on taking value closer to minus 2 or closer to 2, I will see that this quantity will shrink down almost near to 0, and therefore 1 by 0, that is any value which is in the denominator which is very close to 0, then the value becomes very large. For example, if I 1 by 0.1, that is equals to 10. 1 by 0.001, that is actually 1000. So therefore what happens, as x goes closer and closer to 2, the value of this function will become bigger and bigger, but it can't take the value 2. So therefore the value will go up to almost up to infinity. So therefore this is all by inspection. Mind you, I told you that finding range can be a little bit difficult. It has to be done by inspection. You have to just inspect by putting values, and you have to check, and you have to write it. So therefore I can say that the range will be half to infinity. Half, why? If I put 0, it is giving me half, that is the smallest value I am getting. And if I go as close to -2 or 2, I can see that the value will go on increasing and therefore the value will go up to infinity. So this definitely needs some practice and some idea. So I am not going to expect that you will be able to understand it directly. See through the video, try going through the examples of the book as well. You will find different methods of finding domains and range. I'm pretty sure finding domain is not going to be that difficult, because there are certain particular ways of finding domain which is easy. And also let me just tell you, in your syllabus you have only algebraic functions. Algebraic function means it can be a rational function, it can be a polynomial, or it can be square roots. So don't solve those questions where you have to find domain and range of a trigonometric function or an exponential function or a logarithmic function. You don't have them. Fine. So therefore modulus function is also an algebraic function, for the matter of fact. So you can try finding domain and range of modulus functions as well. Modulus function is easy. We already know that all modulus function almost behave the same way, so not much difficult there. The only difficulty you will face is in square roots. That is the only difficult part, where finding range can be a little bit difficult. Anyway, so give it a good read. I am pretty sure you will be able to understand, and we are coming back next Wednesday. I don't want to take class Monday because I want to take a class with the commerce students as well. So I will be taking the next class on Wednesday. Thank you.